Let's have a little look now at what we mean by implied domains, a very important area for you to understand. The implied domain is the largest domain for which the function is defined, or, if it's not specifically defined, the largest domain which makes sense for a function, guys. So we have functions which are naturally restricted in their domains, which I call the fuzzy functions, and there are three classes of fuzzy functions. That's my terminology, by the way. They are the square roots. Now, you know what happens here. What's under the square root sign has to be 0 or positive. It can't be negative. These second class of fuzzies are the 1-overs, in which case the denominator can't be, that's right, can't be 0. And we've got the logs, these ones here, where whatever is in the bracket has to be positive. Can't be 0, can't be negative. Okay, now if you get a handle on that, ladies and gentlemen, you are laughing. You're laughing all the way to full marks. Yes, let's do a little couple of examples here for you. Find the implied domain of the following functions. Okay, we've got 4 of these grisly looking customers here for us to conquer, and it'll be easy because we've got our rules. Alright, let's have a look at A today, hooray. We've got this one. Now we know that the denominator can't be 0, so basically just solve the denominator for 0 and exclude that result from our domain. So we're saying here that if 2x minus 3 was equal to 0, then x would be 3 over 2. So we've got an implied domain, or the maximum domain that makes sense for this function, of everything except where x equals 3 over 2. You get that, don't you? It's very simple. Just follow the rules for the fuzzy functions, yeah? So, okay, B, what do we got here? A square rooty one. So we know that what is in here under the square root sign cannot be negative. So let's solve it for what's under the square root sign is greater than or equal to 0. Yeah? And it's very easy if we do that. So therefore, if we know that 11 minus x has to be greater than or equal to 0, let's subtract 11 from both sides. We get this. And then if we multiply both sides by minus 1, you have to be jolly careful when you do that, because you have to reverse the inequation sign here, the inequality sign, okay? I call it the crocodile mouth, okay? Because I live here in Australia and we've got crocodile. So you reverse the crocodile mouth direction and you're laughing. Alternatively, a nifty way of solving something like this is you could just add x to both sides, and you would automatically get an x over here from doing that. You would automatically get an x over here as a result of doing that, and you would get x is less than or equal to 11 without all the drama of multiplying both sides by minus 1. That's a nice little nifty trick that you might remember to try. So there we go. We've got our implied domain of minus infinity up to and including 11. Very nice. Now have a look at this one. This is an interesting little beast because we've got 2 square rooty ones here. Now, how do we tackle that? Well, we need simultaneously for this to apply and this to apply, don't we? Because this has to work, whatever's under this square root sign must be greater than or equal to 0, and this has to work, whatever is under this square rooty sign has to be greater than or equal to 0. So both of these have to apply at the same time. That's really the cruncher for this kind of beastie. Okay, so let's just work that out now. If we've got x minus 5 is greater than or equal to 0, we know that. If we add 5 to both sides, we get this, and then we get that. Yeah, x is greater than or equal to plus 5. Now, on the other hand, for the second component, this little animal up here, we know that's got to apply, okay? That thing's got to be greater than or equal to 0. So basically, you can just solve that now. If you added x to both sides, you get x is less than or equal to 7. Or if you do it this way, the more traditional way, subtract 7 from both sides, you'll get that, and then you'll get that. And now we have to multiply through by minus 1. And what will we get? Come on, tell me. Yeah, we'll get x is less than or equal to plus 7. Yeah? Yeah, very good. Now, how do we deal with this and this at the same time? Answer, a number line. Saves your life. Absolutely saves your life. So here is our number line representing this beastie up here. Okay, you've got to get x is greater than or equal to 5. And here is the number line which represents what works for x values for this second component, yeah? So you see that? Now, of course, both of them have to work at the same time if we have an implied domain for this combined function. So what have we got? You tell me. Well, yes, that's what we've got. So we need the overlapping part of the number lines, and therefore we know that x has to be from 5 to 7 inclusive. Yeah, do you like that? I think it's very nice. Very, very nice. Now, here's one which just unravels a lot of students, let me tell you. They just don't know what to do with this. We've got a square rooty thing here, and it's basically a quadratic under the square root sign. So, yes, the erratic quadratic under the square root sign. But it's very, very easy to know how to deal with this if you just realise that that's the case and then draw a little sketch graph. The sketch graph is the answer to this. Yes, that's after having factorised it. Okay, let's draw a graph. And let's see how easy this is to work out now. We know there's our quadratic graph of what's under the square root sign here. Okay, and we've got our two x-intercepts there, -3 and +4. And we need the y values. That is, we need x squared minus x minus 12, and this is the graph of y equals x squared minus x minus 12. We need the y values to be greater than or equal to 0. So you have a little squiz at this graph, and can you see where this y value is greater than or equal to 0? Well, ladies and gentlemen, it's everywhere on or above the x-axis as far as this red line goes, isn't it? So there, that's the bit of the graph that we want. So all we have to do now is work out the x values which give rise to that green shaded part of the curve. And that's very easy. We don't want this bit here because that's where the y values are negative. So definitely we don't want that. No way, Jose. So the x values which belong to the green sections of the curve are found by drawing vertical lines, little curtains of lines from the curve to the x-axis as follows. Ah, look at that. Now we're pointing to the x values which we want, which give rise to the green part of this curve, this shaded green part of the curve. And so what is it? Go on, what do you think? Yes, it's everything from -infinity up to and including -3, or everything from 4, including the 4, up to infinity. Yeah? See, isn't it easy when you draw a graph? It's absolutely like magic. So there you go. See? That's the way not to get those wrong.